Hello and welcome to the first marathon for integration by parts. As I've done before, I will be solving a number of integration by parts questions for you to understand the concept. Okay, looking at this first question, our first step always is to write the acronym ILATE. Once you've written that, you circle the two categories that you have. You have algebraic and trigonometric. The first in this category is called hue. The second in this category is called V dash. To go to u dash from u, you simply differentiate, and to go to v, you integrate. The integral of sine x is minus cos x. Uh, so that is what you have. Then you write down the formula vu minus integration of vu dash vu. So that's minus cos x into 2x into 2 into x squared minus cos x into 2x. I have minus x squared cos x plus 2x cos x. I have taken the minus outside and multiplied the two negative signs together. That gives me a plus outside. Again, what I have here is again an integration by parts. So I'm going to again write the algebraic and the trigonometric again. I have the same categories again, ILATE. So u dash is 2, v is the integration of cos x is sin x. So I get vu minus integration of vu dash vu sin x into 2x into sin x into 2. So I get 2x sin x minus 2 and integration of sin x. Again, integration of sin x will be minus cos x. So that will give me minus cos x. Now to apply the limits, I will have to apply the limits on the entire thing. So I'm just going to write that once more, minus x squared plus minus x squared cos x plus 2x sin x, and it's going to become plus 2 cos x. Applying the limits are 0 to pi. So I get minus pi squared cos pi plus 2 pi sin pi and 2 cos pi minus. The first term becomes 0 because I have x squared. The second term also becomes 0. The third term becomes 2 cos 0. So this becomes cos pi is negative 1 plus 2 pi sin pi. That's 0. Sin pi is 0. And cos pi is again negative 1 minus 2 cos of 0. Cos of 0 is 1. Therefore, this becomes minus 2. So I get pi plus 0 minus 2 pi minus 4. That is my pi squared minus 4. Yes, that was pi squared. I missed the squared. Pi squared minus 4. That's the first question. Let's look at the next one. This has just the first part. Possibly the next part is numerical solutions to equations. That is what this usually does, but that's for another day. I'm going to solve the first part for you. It says x cos x integrated from 0 to a gives you 0.5. So again, I write my ILATE and I circle the two categories that I have. I have u as x and v dash as cos x. The integration is sin x and the differentiation is 1. So I write vu minus integration of vu dash vu. So sin x into x sin x into u dash is 1. So I get x sin x, and the integration of sin x is minus cos x. That is what I get, and I have the limits. 0 to a, they should go down to 0.5. So I have x sine x plus cos x with limits 0 to a equals to 0.5. So I have a sine a plus cos a minus 0 sine 0 plus cos of 0 equals to 0.5. A sine a plus cos a minus 0 and minus 1 equals to 0.5. So that gives me the 1.5 that I wanted. It also gives me 1.5 minus cos a that I wanted, and I just need to divide by a. So sine a is therefore 1.5 minus cos a divided by a. Okay, moving to question number 3. It says it is given that this, again, this is the same type of question. So let's write isolate. There are two, algebraic and exponential. So I'm going to say that u is 4x and v dash is e power minus half x. So v is therefore e power minus half x divided by minus half, which gives me minus 2 e power minus half x. U dash is 4. I'm going to write my formula vu minus integration of vu dash. So minus 2 e power minus half x into 4x minus 2 e power minus half x into 4. I can pull out a plus 8, minus 8 outside, which makes it a plus 8. So integrating this again gives me 8 e power minus half x divided by minus half, and I have this on the other side. Then I have the limits from 0 to p, and this should equal 9, and I need something in terms of ln. So I'm going to say 0 to p equals to 9. So minus 8x e power minus half x minus 16 e power minus half x from 0 to p. Now I find it easier when I have e power minus half x on both terms to pull something out as common so that it bothers me a little less. So I get minus 8x minus 16 inside, and the limit is 0 to p. Okay, applying the limits, e power minus half p minus 8p minus 16, and that's the upper limit. E power 0 and minus 8 into 0 minus 16 equals to 9. So this gives me plus 16 at the end of the day. Okay. Then I think the easier thing to do is to, it's a complicated proof, so I'm going to take this to the other side and tell you that 16 minus 9 is minus 7. Do we have a 7 in the denominator? So that makes it a little encouraging that I might have the right answer. And what I then need is this. So I can say that this is minus 7 over minus 8p minus 16. I see all negatives. I can factor out a negative and cancel it both in the numerator and in the denominator. And I don't need this fraction, I need the reciprocal of this. So that's what I'm going to do. I'm going to change this to a plus sign. The power becomes positive, and this becomes 8p plus 16 over 7. Then I use ln on both sides, or convert an e to an ln, whichever way you understand. And this becomes ln 8p plus 16 over 7. And p becomes 2 ln 8p plus 16 over 7. I think that's the correct answer. Yes. So that's the entire solution. Then we have question number 4. It says the diagram shows a sketch of the curve this and its minimum point M. The curve cuts the x-axis at the point 1, comma 0. Find the exact value of the x-coordinate of M. So M is the minimum point, which means that I must find it with differentiation. When I start differentiating, I see that this is a product rule. So I'm going to say that u is equals to x power half, v equals to ln x. U dash is half x power minus half, v dash is 1 over x. So I have dy by dx as u dash v plus v dash u. So I get ln x over 2 root x, if I were to write that as this. And this also gives me, since I have half in the numerator and 1 in the denominator, I can also say that this also becomes root x. This becomes easy to solve. Then I need to equate this to 0. So I get minus 1 over root x equals to ln x over 2 root x. Or I can just take an LCM. Let's just take an LCM. That's easier that way. So I have 2 root x as the LCM. I have ln x plus 2. And I get this gets cross multiplied and equated to 0. And I get minus 2 equals to ln x. X is therefore e power minus 2. So that's the exact value of the x-coordinate of M. Then it says use integration by parts to find the area of the shaded region enclosed. So I'm going to first write my expression. From 1 to 4, I am integrating x power half ln x. This is again an integration by parts. I'm going to write a dx. So this is integration by parts. I'm going to write isolate first and say that I have an algebraic and I have a logarithmic. The logarithmic comes first. Therefore, u equals to ln x and v dash equals to x power half. V equals to x power half plus 1 divided by 3 over 2. And I'm going to simplify that. U equals to 1 over x. Again, I'm going to write my formula vu minus vu dash. And I get 2 over 3 x power 3 over 2. U is ln x. Giving your answer correct to 2 decimal places. I can use my calculator to do all of that. I don't need to do this manually. 2 over 3 x power 3 over 2. And I have 1 over x. So 2x power 3 over 2 ln x over 3 minus integration of, again the powers get subtracted first, so I'm left with half in the numerator. Again integrating this, 2x power 3 over 2 again, so 3 into 3 over 2. Okay, and I have the limits 1 to 4. Then I can just plug in the limits. I don't need to do all of this manually. I can put it on my calculator, and that's what I'm going to do. I don't even need to simplify any of this, although it would have been better if I had taken out a common, but that's okay. Just moving to the left so that I have some space. And this one becomes 0 because this is 1 because ln 1 is 0 and okay, that's 9 over 2. I made a mistake there. Okay, putting all of this on a calculator, and I know that I have 2 into 8 into ln 4 over 3 minus 2 into 8. Root of 4 is 2 and 2 cube is 8 divided by 4.5 The first term is 0, the second term is plus 2 over 4.5. Yeah, I get 4.28245 So correct to two decimal places is 4.28. That is what the correct answer is. Moving on to the next question. Question 5 says that the diagram shows a curve this and its maximum point M, the shaded region, and the curve and the axis is denoted by this. Find the x coordinate of M. So I know that I need to do the product rule. This is a lot more complicated than I would have expected it to be. So this becomes minus e power minus half x. I'm differentiating. So e power minus half x into minus half. V dash is 1 plus 2x half outside because I've pulled down the half. Then I've subtracted a negative 1 and then I multiplied it by 2 as well. Okay, the differential of the bracket. So dy by dx gives me u dash v v, that's right, root of 1 plus 2x. Need some more space, plus v dash, which is basically 1 over root 1 plus 2x, and v dash u. So what I see is that I need to equate this to 0. I need to copy this and bring it down. So equating this to 0, I can pull out the e power minus half x common. That gives me minus 1 plus 2x over 2 plus 1 over root 1 plus 2x. So either this equals to 0, which is not possible because ln 0 is not possible, or that equals to 0. Solving this is easy. I keep this term on this side and take the other term on the other side. When I cross multiply, it gets rid of the root. So I just have 1 plus 2x. So that gives me 1 equals to 2x, x equals to half. That is what the question wanted. It wanted the x coordinate. Then for part 2, it says find by integration the volume of the solid retained completely above the x-axis. So I need to know this point first so that I know the limit. So what I'm going to do is I'm going to first equate the curve to 0. I'm going to find the x-intercept. I have either this equals to 0 or that equals to 0. So I have 1 plus 2x equals to 0. X equals to minus half from here. So this is minus half. This is not possible. Then when you are doing a volume, it's best to first write down what your expression is so that you know exactly what you are trying to integrate. So volume is basically pi times the limits minus half to 0 of the function squared. So you have to first square the function. I'm not going to write the pi limits repeatedly, but I'm just going to show you the first step where I write them in the function and square it so that I know what type of integration I'm getting into. So that's root 1 plus 2x, and there's a full square outside. When each of these terms gets squared, I get e power minus x because the square cancels out with the half, and the other one that I get is 1 plus 2x. Okay, so that is the first thing that you need to do, and then what you do is you start thinking how to integrate this. So this is again an integration by parts. So I write down my ilet. I have an algebraic and I have an exponential. So u is my algebraic and v dash is my exponential. So v is therefore e power minus x divided by minus 1, and u dash is 2. So vu minus integration of vu dash vu, that's minus e power minus x into 1 plus 2x, minus e power minus x into 2. So again, what I can do is I can say that this becomes this. I brought the minus outside and the plus outside, and the 2 outside as well. So this becomes minus e power minus x 1 plus 2x, and that again integrates to minus e power minus x. And I have the limits minus half to 0. So I'm going to say, and there's a pi outside as well. The easy way is to pull out a minus e power minus x common and say that 1 plus 2x plus 2 minus half to 0. So when I have e power 0, this becomes minus e power 0, and this becomes 3 inside. And when I have minus half, this becomes minus e power plus half into 1 plus 2 into minus half plus 2. Okay, so this becomes minus 3. And what does this become? It cancels out and this becomes 2 e power half. And there's a minus here as well, right? That's something that I missed. That's the upper limit and that's the lower limit. So this becomes 2 e power half minus 3 pi. Let me check if that is the correct answer. 2 e power half minus 3 into pi. Yeah, I have the correct answer. The next question, question 6, tells you the diagram shows a curve x power half ln x, the shaded region between the curve, the x-axis, and the line x equals to e is denoted by r. Find the equation of the tangent to the curve at the point where x equals to 1. So I know that I'm going to need the y coordinates. I'm just going to quickly do that. 1 power half ln 1. So that gives me 0. ln 1 is 0. So y coordinate is 0. So this is probably 1. And at the point where x equals to 1, giving your answer in the form y equals to mx plus c. No, I think I made a mistake somewhere. Okay, no, this is fine. Y equals to 0. This should be 1. That's the x-intercept of the line as well. So that makes the calculation a little easier for me. Okay, then dy by dx is something that I want. Again, u and v, because I have a product rule here. U equals to x power half. U dash is half x power minus half. And v is ln x. So v dash is 1 over x. So dy by dx gives me u dash v plus v dash u. I don't need this at 0. What I need is the value at 1. So that gives me ln 1 again, and 1 power half divided by 1. So this gives me 0 plus 1. So the gradient is also 1. Quickly constructing the equation of the line here for you: y minus y1 mx minus x1. So y minus 0, 1, x minus 1. So I get y equals to x minus 1, and that's the correct answer. Part 2 says find by integration the volume of the solid retained when the shaded region is rotated completely about the x-axis. Okay, so again, I have to write my expression first. I'm integrating from 1 to e, and I have to square this. So that's an interesting question because we've never seen ln x getting squared. So this gives me x and ln x in a square, and I have this. So I'm trying to integrate this now. I again write my I late, and I can say that I have algebraic and logarithmic. So the logarithmic comes first, which means that I have to differentiate this first, and v dash is x. So v is x over x squared over 2, and u dash is 2 ln x power 1 into 1 over x. I've used the power rule here. So I get vu minus integration of vu dash vu. So x squared over 2 ln x in a whole square, x squared over 2 into 2 ln x power 1 into 1 over x. So some things cancel out, 2 and 2 cancel out, and I notice that I now again have another integration by part here. Here I can say that again I can put a bracket. I can say that again I again have I late logarithmic algebraic 1 over x, v dash was x, v is therefore x squared over 2. So I get vu minus integration of vu dash vu and v q dash. So this becomes x squared over 2 into 2 because this was x power 1. I integrated it again. So that is what it becomes. X squared ln x in a whole square over 2 minus x squared over 2 ln x plus x squared over 4. And I have the limits 1 to e, and there's a pi outside. What do I have to? This is what I'm getting to. Those are the answers. So let's see if we get the answers. Now again, I see that I could, sort of make it easier by pulling out an x squared common and a 2 common as well. So I'm going to do that, and I'm going to make it easier before I apply the limits. Ln x squared minus ln x plus 1 over 2. So this becomes e squared over 2. Ln e is 1. So 1 minus 1 plus half. That's the upper limit. The lower limit is 1 over 2. Ln 1 is 0. Ln 1 is again 0. And plus half. So I get, this cancels out. I get e squared over 4 minus 1/4. Is that the answer that I was getting to? Yes. So 1/4 pi e squared minus 1. That's my final answer. Although there's more space on the next page. If you're doing this, you can use the next page as well. Okay, so that is the final answer. Moving on to question 7. This looks relatively easy. It's a simple question on I late. I have algebraic and I have trigonometric. U is x square and v dash is cos 2x. V is therefore sine 2x divided by 2. U dash is 2x. Writing down the formula quickly. Vu, so sine 2x over 2 into x squared, sine 2x over 2 into 2x. So I have another level of integration by parts. Again, I'm going to write my isolate, algebraic, trigonometric. This is v dash, so v is therefore minus cos 2x divided by 2. So vu minus integration of vu dash. Vu, and u dash is 1. So minus x cos 2x over 2. I'm going to pull out the minus or plus outside and half outside as well, and say this. So minus bracket minus x cos 2x over 2. And then this integrates to, okay, I've pulled out the 2 common. There's no 2 here, half. And this becomes sine 2x over 2. So I have minus bracket minus x cos 2x over 2 plus sine 2x over 4. So writing the entire thing and then plugging in the limits 0 to pi over 4. So I have x squared sine 2x over 2 plus x cos 2x over 4 over 2 minus sine 2x over 4. 0 to pi over 4. There's nothing that I could take common, so let's just go with the flow. So that's pi squared over 4 sine 2 pi over 4 over 2. Complicated sort of. Plus pi over 4 cos 2 pi over 4 over 2 minus sine 2 pi over 4 over 4. That's the upper limit. The lower limit becomes 0 because x squared is 0. Then the other one also becomes 0. And the last one also probably will become 0. So I just have the upper limits. Sine 2 pi over 4 is 1, so this becomes pi squared over 8. And so 1 over 32 outside. Um, This should be pi squared over 16, so that's 32. So pi over 4 into 2 pi over 4 cos pi over 2 is basically 0, so this becomes 0, and then this becomes minus 1 over 4. So I have pi squared over 32 minus 1 over 4. I take an LCM, just 32, so this becomes pi squared minus 8, and I can write it as 1 over 32 pi squared minus 8. That is the entire solution to this. Then I have the same question in terms of theta, so let's quickly do that too. I have isolate, I have algebraic, I have trigonometric. So u is theta and v dash is sine half theta. So v is minus cos half theta divided by half. So u dash is 1, vu minus integration of vu dash, vu minus 2 cos half theta, theta, minus 2 cos half theta, 1, minus 2 cos, minus theta cos 2, 2 theta cos half theta, plus 2 cos half theta, minus 2 theta cos half theta, and integration of this will give me 2 sine half theta over half. So that gives me this, and I can apply the limits 0 to pi over 2. So I get minus 2 theta cos half theta plus 4 sine half theta. Applying the limits 0 to pi over 2. Minus 2 pi over 2 cos, this is a root, yes, divided. The lower limit becomes 0 for the first one because there's a 0 there, and 4 sine of 0 will also give me 0. So it's just this one that I need to solve. This becomes minus pi, cos pi over 2 is root 2 over 2 according to your calculator, and 4 root 2 over 2. Now, this bothers a lot of people that I'm not getting the root 2 in the denominator. You shouldn't be getting a root 2 in the denominator ideally, unless it's a show that question, because you've used your calculator. So your calculator gives you sine 45 as root 2 over 2, which is technically equivalent to 1 over root 2. So if I were to use 1 over root 2 instead of root 2 over 2, I would get the answer that's there in the marking scheme. This is not technically the marking scheme, this is the examiner report. So this is a perfectly fine answer as well. I can say that I have root 2 common, I have 2 common, and this becomes 4 minus pi. I'm getting the exact same expression, there's no problem with that. Okay, that is this. You can see the answer there. Okay, then question number 9. It says find the exact coordinate of m. The diagram shows a graph of x cube ln x and its whenever point m. So this is again a question on differentiation. U equals to x cube, u dash equals to 3x squared, v equals to ln x, v dash equals no, oh yeah, v dash equals to 1 over x. So dy by dx, this is a simple differentiation question. It seems you don't need to write isolate. That is what where my mind went, and it shouldn't. X cube 1 over x. So equating this to 0, I see I have x squared common. So 3 ln x plus 1. Either this equals to 0 or 3 ln x plus 1 equals to 0. Ln x is therefore minus 1 over 3. X equals to e power minus 1/3. And since I'm looking for the y coordinate as well, exact coordinates, so I'm going to say that cube ln e power minus 1/3. So this gives me e power minus 1, and this comes down 1 minus 1 over 3 ln e. So that gives me minus 1 over 3e. Yes, I have the x coordinate and I have the y coordinate. Then it says find the area of the shaded region bounded by the curve, the x-axis, and the lines x equals to 2. So I will need this point, so I equate the y to 0. So either this equals to 0 or that equals to 0. So x is 1. So I'm going to integrate from 1 to 2 x cube ln x. Isolate. I have logarithmic, I have algebraic. So u is ln x, v dash is x cubed. V is therefore x power 4 divided by 4. U dash is 1 over x. I think that's a simple question from there. Vu minus integration of vu dash. Vu. Integrating that again. So 2 power 4 ln 2 over 4 minus 2 power 4 over 16. 1 power 4 ln 1 over 4 minus 1 over 16. So that gives me 16 ln 2 over 16 over 4 minus 1 over minus 16 over 16 minus 0 plus 1 over 16. So 16 ln 2 over, not 16 ln 2, that's 4 ln 2. 4 ln 2 minus 15 over 16. Yes, that is my correct answer. The last one for this exercise is this one. I think that's a relatively simple question. Algebraic and exponential. So u is x, v dash is e power 2x. So vu minus integration of vu dash, vu e power 2x over 2. So x e power 2x over 2 minus e power 2x over 2 into 2 now. And the limits are 0 to 1. Yeah. 1 e power 2 over 2 minus e power 2 over 4. 0. So I have e squared over 2 minus e squared over 4 plus 1 over 4. That is the final answer, e squared plus 1 divided by 4, and that's what your answer in the marking scheme also is. Thank you for watching. Please like, share, and subscribe. Also comment if you have any questions, and I will be back with another video.